Thank you, Jason, for inviting me. Thank you for having me. Good evening, good morning, good day to all of the speakers, which part of the world you're coming from. Jason is in the United States. I'm in Europe, so which makes us evening in Europe, sort of like noon in United States. So the topic today will be Azure Data Lake Analytics, which is a service available in Microsoft Azure. And we will make a dive into what's available, what can be done, and stuff like that. If you have any questions, please put your questions into the chat box, and we will have like 10 minutes before the end. We will have a slot for Q&A. A couple of words about me. You can find me on the internet. I have a blog. You can email me. I try to email back all the questions if people are asking. Follow me on Twitter, LinkedIn, GitHub, and stuff like that. But otherwise, I've been dealing with data science, SQL Server, databases for the past 15 to 20 years, and I am, as you can read, an avid coffee drinker and a fixed gear bicycle junkie. So the data lake approach. The data lake approach is something new which has happened a couple of years ago due to the vast and fast amount of data growth. Just for the comparison, until 2011, I think it was, the amount of data we've gathered until 2011 is basically equals to the next year. So 2012 equals all the data we've gathered until 2011 and so forth. So the growth of the data is basically narrating the change, how we're going to store the data, how we're going to get the data, through which channel we're going to get the data. You can see that usually we were doing it analogically, then everything started to go digitally, and then mobile and cloud. And with this approach, also the traditional data warehousing approach is sort of like changing. Beforehand, in the 80s, in the 90s, we would be gathering requirements and then sit down with business people, sit down with technical people, sit down with project manager and get all the requirements, which would then lead into development and implementing data warehouses. So first of all, we would have all the installation, all the servers, and then ETLs running through, doing additional data marts and modeling, and on top of that, you would have reportings and analytics. Saying that, that things are basically slowly changing now because, with the vast amount of data, sometimes you just ran out of time to do all the ETLs, to do all the proper data warehousing, because tons and tons and tons of data in different formats is coming in. And this is basically a great time to introduce what Azure Data Lake is. It basically is for storing huge and big data, so huge amount of data in terms of the big data. It basically gives the enterprises, the whole stack, which you can just plug in and start being productive from day one, and you can basically run batch-wise analytics on any kind of data, on any kind of size. And the components are basically, this is basically a ecosystem of the Azure. Just a small portion of this, which you can see in the green part, is basically what Azure Data Lake is. And Azure Data Lake is basically very tight connected to Azure Data Lake Analytics, which basically can give you some insights of the data. But you can tell and you can see that, from different sources, different applications, you would get data in through different hubs, and then storing the data, doing something with the data, and then getting the intelligence or the information out of that. And of course, this is part of the Cortana intelligence suite, which you can get in Azure itself. Okay, so the data lake approach, as I said, get in any kind of data. So it basically ingests any kind of data, regardless of your requirements, which of course can be very convenient. So you can get, from the movies, from the pictures, from the sensors, from text files, whatever you got, you just let it in, store all the data in basically native format without schema definition, and then on top of that do some type of or some sort of analysis. Of course, it would be very naive, so to say, that of course you can do analysis without preparing the data. Yes, we still need to do some preparation, we still need to do some data cleaning and stuff like that. But the core focus here is, you don't need to do schemas. You don't need to predefine the schema. What do you want to do? What type of the data you are getting in? You are just basically getting in any kind of data and storing it, and then later doing so-called batch queries. You can also do the interactive queries. You can do real-time analytics, and on top of that, you can of course do some sort of machine learning. Once you have all the data ingested, of course, you can then also push it to the data warehouse. Got a lot of questions. What is the difference between Azure Data Lake and HD Insight? There are, in terms of pricing and in terms of provisioning, I think there's huge difference. For instance, in the Azure Data Lake, you basically don't need to provision. So you just take this as a service and you go pay as you go. Whereas in HD Insight, you are basically provisioning by clusters. On the other hand, when you're working with AD Insight, you need to specify the number of nodes within a cluster, whereas in Azure Data Lake, you just define the number of parallelism for a particular job, for a particular batch job that you want to use. Based on that, of course, is again that how much you pay. The more parallelism you get, the more you pay. Azure Data Lake, on the other hand, is optimized for a storage of a big data analytics and workload, whereas the HD Insight basically is more object store orientated for storing for particular scenarios. And Azure Data Lake, of course, has the Active Directory identities. On the other hand, HD Insight can do that, but there is some more additional, work to do, like accessing signature keys, authentication, and stuff like that. With HD Insight, you get some limits. With Azure Data Lake, basically the only limit is, the money you can spend on that. So it basically does not have any limits in terms of the account size, file size, number of files, and stuff like that. The only thing to think about is the redundancy. The redundancy for Azure Data Lake is basically just local redundant storage. So this is, if something has changed in the past month, I'm gonna take this information back. But this is 1 month old information. So Azure Data Lake supports local redundant storage, which means that every file will be copied 3 times within the same location on 3 different servers. Whereas with HD Insight, you also get geo-redundant storage and zone redundant storage. So zone redundant means that you get the same copy within the local, but then you have in a different zone another copy. With the geo, you get like thousands of miles away, basically in different geolocation, again 3 times the same copy. The difference, of course, is whenever you have a failover problem or disaster recovery, the geolocation would definitely give you much better response and much less data loss as in terms of the zone or local redundancy storage. But the best and of course the most expensive is read access geo-redundant storage, which basically does synchronously copying the data to a different location, geolocation, whereas Zone and Geo are doing that asynchronically. And the last thing in terms of the comparison is the pricing. With the pricing, it's kind of if you go to the Azure, your Azure account, and you just start playing with the calculation. For instance, I took in this case 5 terabytes of data. I specified the number of read transaction and number of write transaction. In this case, of course, usually you would have read transactions more than write transactions. But as you can see, that the write transactions are 10 times more expensive than read transactions. So I said, okay, 100,000 of read and write transactions for 5 terabytes of data, and you can see the amount of data, the bill, basically it goes $5,000 per month. On the other hand, if I take HD inside, and I take, okay, I'm going to take the same capacity, I'm going to take roughly the same input and output information, data retrieval, data write, but I'm going to store it as a local redundancy, which is basically equivalent to Azure Data Lake, but in type of the blob, which of course is very good for HD inside, and you can immediately compare the prices. It's like $100 versus $5,000. Again, I can play with that even more, and I say, okay, now I'm going to take type, table, and queue, still in LRS redundancy, and I'm going to take 50 terabytes of data, and I still cannot compete, with the amount of data I can store in HD inside. In terms of the pricing, you can still see, I have $3,700 versus $5,600, and even more, I can go and say, okay, now give me the read access geo redundancy, and only then I can sort of like compete with Azure Data Lake. But as I said, again, you don't need any kind of provisioning, you don't need any kind of, there's basically no limit to what kind of data you want to store, etc., etc., for the Azure Data Lake. Azure Data Lake Analytics. So Azure Data Lake Analytics is basically doing analytics on any kind of data, any type of the data, which basically would allow you to build any custom algorithms using the .NET or R or Python. And again, it basically scales efficiently to any kind of size or any kind of data. Azure Data Lake is basically enterprise ready. It basically does all the security, all the support. It basically virtualize your analytics if you want to do any more advanced analytics. You can start immediately, and you can do any kind of development in terms of the parallelism, very massively parallel programs. You can do that pretty much simple. This is due to the fact that all of the analytics basically is batch oriented. Of course, you can combine any kind of data. You can take XML, JSON, text file. You just put it in. Let's say you don't know what kind of data it is. You don't know what kind of data is coming in, and you can do all the preparation, pre-processing, transport, and reformatting. That, of course, is batch oriented. And then you can do all the ad hoc batch queries like load, transform, aggregate, and consume, building models which you can then of course expose to Power BI or to Azure Data Lake, Azure Data Warehouse and stuff like that. All this basically is done extremely fast. Just once you have defined .NET not the libraries, assemblies, you can of course do that extremely fast, but it will take some time for the preparation. Let's say that you have some complex JSON files or complex XML files. It will take some time to preparation, but you can start drilling down with simple analytics immediately. Azure Data Lake Analytics will definitely work across any kind of data, so you can take data from virtual machine, SQL Server database. You can take from the storage blobs. You can take from the Azure Data Lake store, Azure SQL database, or even Azure SQL Data Warehouse. Any kind of data it will take in, but querying the data, it will basically work on the Azure Data Lake storage and Azure storage blobs. This will definitely allow you to do read and write, whereas with the others, you can basically just query the data, which means that you can read the data, but you cannot store the results of the data. So you would need just some Azure Data Lake storage to write down the results, and we will look a couple of slides later why is that. But basically, querying the data in Azure Data Lake Analytics, it basically means that you don't need to do any data movement across the network. So basically, you can do that between the stores, Azure Data Lake stores, different kind of stores. You don't need a single data store, which means that you can have multiple, and you can just combine them when you're writing these queries. Of course, you can also have a single view of data irrespective of the physical location, and you can minimize multiple data copies, which means, of course, less data movement, which means less errors, less different data sets, or basically just one version of truth. And of course, single query language for all the data. This is true, and it's called U-SQL. The next slide we will go diving into that. And of course, each data store maintains its own sovereignty, and all the SQL expressions can be used to remote SQL sources, so to call and do all the remote SQL sources. So this single query language is called U-SQL. U stands for unified or universal, or you name it. But what are the benefits of this language? Basically, it is declarative SQL, which comes with a custom imperative C# code, which kind of sounds funky. It is, but it's very efficient. You can do basically unstructured and structured data very easily. Microsoft says you can increase your productivity and agility from day 1 and at day 100 for you, which is true, but sometimes you will see that it might take some additional effort to do all the preparations, especially if you want to do the SQL coding. You have to prepare a C# assemblies. So the origin of U-SQL is basically a scope which was Microsoft's internal big data language, which is basically SQL and ANSI SQL, SQL and C# integrated kind of language. It is optimized for scaling large data. At Microsoft said they're basically running 100,000 jobs daily in this scope language. It is also the combination of Hive, which is a very strong for dealing with types of data such as arrays and text files, and of course it is a ANSI standard SQL or Transact SQL language, which basically comes as a native SQL language, but it supports also all the capabilities such as procedures, functions, data types, any kind of window functions that you want to do, metadata models and stuff like that. So this is basically what U-SQL comes. It's sort of like a mishmash, sort of like a mixture of different languages. So on the right-hand side, you can see that this is basically how the U-SQL code would look like. It is very understandable. You can read it immediately, but there are some, parts which I would like to go through for you to easier to understand what is basically running in behind. As I said, the U-SQL language concept is basically that it is sort of like an expression type of programming language. It is a functional lambda, it basically uses functional lambda expressions. It can be composable globally and locally, and it's globally optimizable. It, as I said, operates on structured or unstructured data. So basically schema on read over files, and you can see those that are basically written covered in yellow. So on the right hand side you can see input orders.txt and input customers.txt file. So what does this mean, schema on read over files? It means basically that you don't need to define the schema of the file. You just say extract me this and extract me that. So let's assume that in orders.txt I have, you know, day of order, number of day of order, the total value of the order, the products, etc., the tax and stuff like that. And let's say I just want to extract the date and the tax. And I'm not worrying about if the tax comes the first column or the second or the third column or the last column, or let's say that I have a couple of those ordered text files, and some files have, for instance, also customer ID inside where the others don't have. I don't need to worry about that. I just say, you know, to the U-SQL, just take me the value added tax and take me the order date. And just those two columns, which means that basically when the file is read, it basically loads up the schema, which I don't need to predefine. It also supports the relational metadata objects, such as creation of the tables, of the indexes, of the views. You can do a simple insert statement, update statements like you would find in standard SQL language. But it also is extended to C#. That means, what that means is basically that you can create your types, you can do a .NET expressions, you can do user-defined functions, user-defined aggregators, and user-defined operators. In my opinion, user-defined operators are the nastiest one, and you have to be really careful with that. But user-defined functions, for instance, if you take a look at the greens, so on the right-hand side you will see my namespace.myfunction is very easy to write. So you just create a reference, so you just create an assembly and you write that in .NET. So you use C# language to say what you want to do with this function, and you just deploy it and then reference it in this U-SQL language, which is absolutely awesome, but kind of reminds me of, if you go back to the Transact SQL, you know, all those CLR languages and functions, basically it's the same, yeah. And also the same goes for aggregators. With aggregators, you will find some of those aggregators, if you are not familiar with U-SQL language, very unpleasant. Why? Because, you know, Transact SQL has developed over the years, and all these functions, nice functions that are coming constantly with new versions or updates, are awesome when you want to write, you know, some queries fast and quickly. With U-SQL, you will find that, for instance, a date function would be sort of a problem, because there is no date out of the box date functions, especially, you know, imagine cast convert to a different data type using, let's say, datetime format, zones and UTC and stuff like that. You don't have that. Such simple functions, you don't have that. So you need to basically write that on your own, or don't do that, just Google it. Probably somebody has already wrote it and reuse it. So don't reinvent the wheel, but the concept is that, you don't get anything from the beginning. So all those little nice functions, aggregations, operators, you need to write that on your own. Otherwise, U-SQL basically provides a framework that basically can do the parallelization and scale-out framework. It comes also with the clauses like extractors, outputters, processor reducers, which basically can help you do the data munging or data wrangling, so to say. So you can extract, you can output, such as output would be, stored there, extract would be read from here, etc., etc. And as I said, U-SQL, the U-SQL queries can be federated across distributed data systems as well. So I've mentioned that U-SQL is basically sort of extended language of Transact SQL with combination of .NET or C# language. So you can use the C# expressions, of course, in select statements or in extractor statements or in outputter statements. You can write your own user-defined functions, user-defined aggregates, also user-defined operators. You can see that those are backstabbing, but just be cautious when you're writing them. You can also use any other assemblies from the internet. You can download it from NuGet. You can use any other assembly that is available in .NET. You can also reference to a .NET Framework assembly, and you can use the R or Python extension to do any kind of predictive analytics. Microsoft has also provided, in the scope of this Cortana intelligence, a lot of cognitive assemblies, which will help you do so-called unstructured data reading and recognizing. So I will just briefly show you in the demo what these cognitive assemblies are, but these are, let's say, OCR for text, or recognizing the faces or emotions and stuff like that. And last but not least, PowerShell scripts. Azure Data Lake can be run through PowerShell scripts. I'll also show you that very briefly. You can basically federate, navigate also the whole U-SQL through PowerShell. But having said that, I will rather not talk about PowerShell because it's a hot topic as well. Okay, finally, U-SQL Analytics. Out of the box, you will get the window expressions, which is basically, your normal Transact SQL language. You can do over partition by class, order by class, row by class. You can also do windowing aggregate functions like, your typical mathematical or statistical functions, standard deviation, variance, counts, any kind of stuff. Also analytical functions, last value, first value, percentile count, cumulative distribution, lead lag, per rank, percentile, and stuff like that. And also ranking functions, which are also very useful, dense rank, entile rank, and row number. And this is basically what comes out of the box for the U-SQL Analytics. This is basically it. Having said that, yeah, there's not much more than that. Of course, you can use then Python, or you can use R if you want to do any kind of, really sort of semi-advanced, advanced, or even, machine learning processes. All those processes, of course, will be batch-wise orientated. Again, or you can, do any kind of data aggregation, data preparation, and store the data into a Azure Data Warehouse and use this Azure Data Warehouse data and go to the machine learning lab and do in Azure and do, any kind of advanced statistics there. So the U-SQL execution looks something like that. So you will get a tree or the model or the execution plan, which will basically tell you what is going on. So in this case, if you look the SV1 extract, you can see that there is like 487 vertices, which means that, you know, this is 487 tasks, in this case files, that needs to be you know, read, and the process needs to do something with those files. You can see that R and W, which means read and write, the number of rows that basically has been read, and then it just goes on and on and on. At the end, you will see that all these results are basically stored in some files. You can see that altogether.csv or altogether number of users CSV and stuff like that. This is basically automatically created execution plan, which you cannot basically tweak. You just get this so that you know what's going on. Also, the system does all the parallelization on its own. You can just define number of AUDs, which means the number of parallel processes, and that's about it. Once you click on one of those boxes, you can get all the detailed information about that. Also, debugging can be done, but it is pretty nifty. I will show you how, and the error messaging is just tremendous. Of course, there are also colors which can tell you and denote, you know, if it's green, which means fine, if it's red, which means oops, something went wrong, if it's brown, you know, if it's brown, it means something got stuck up, you know, go and dive into the code and see what's wrong. Anyways, so the processing goes something like that. So you can do that from your Visual Studio, or you can do that from the internet. So you go to the portal, Azure portal, and you can do everything there. Once you do that, you can schedule a job, you can queue a job, and the compiler will just tell Optimizer what to do. And then in real time, you know, you can do any kind of runtime executions and also vertices scheduling. So the vertex scheduling is basically every single line here is basically a vertex. And then the results can be driven back to Visual Studio, the portal, or you can also call that through APIs. And the tools available basically are, as I said, you can go to the portal, or you can stay in the Visual Studio. Again, this is a slight comparison so that you will know what basically is plus and what is minus. The pluses are basically colored in red. So you can authorize, or you know who the author of U-SQL script is in Portal and in Visual Studio. You can debug U-SQL and .NET code in Visual Studio, whereas in Portal you will not be able to do that. You will just get a beautiful error messages, which of course for the same error can also be slightly different between Portal and Visual Studio, but never mind. You can start and stop or repeat U-SQL jobs either in Portal or in Visual Studio. You can visualize and reply, as I said, progress job. Also in Visual Studio you can visualize the physical U-SQL query plan, which is not possible in Portal. In Portal you can do overall job management chart and user statistics, so compute hours, which is very important because also this will be part of your billing system, and this cannot be done in Visual Studio. You can fine-tune query performance in Visual Studio, but in Portal you can provision user who can submit jobs, whereas in Visual Studio you cannot do that. You can also fine-tune query performance in Portal, and in Visual Studio you can create metadata objects, and you can also browse through metadata catalog, which in Portal is still not do that in Portal. So this is debugging. It is kind of really not appealing once you get something like that. You know, you see all the diagnostics and then the resolution. I think this is for the winners. You know, it says, you know, make sure that the bug in the user code is fixed. So this is part how U-SQL will tell you, how to solve your problem. Yeah, get that bug fixed. So this is the core. This just makes me, not happy, but I'm laughing every time I'm looking at that. A quick slide about billing. As I said, pay for the compute hours for a query, pay for the storage, of course, separately. There is this ADLAU allocation, which can be calculated. So there's the cost. Sorry. You can allocate 10 ADLAUs for 10 minutes job, which will cost you, so 10 minutes multiplied by 10 units, which will basically mean 100 minutes of that. So this is the formula. This is general availability price starting from the January 1st, 2017, how much you would pay. And consider about that. Either you go over location or under location. What does that mean in terms of the cost, and what does that mean in terms of the price performance? Anyways, so finally demo. I'm just gonna quickly jump into my Visual Studio. So this is my portal, and you will be basically using Azure Data Analytics. So I said that you can start a job from, for instance, from portal. So basically you can either start writing a job here or copy pasting the job from Visual Studio. So this is my Visual Studio, and I'm just gonna go with the first example. So the first example will say, so this is your typical U-SQL. If you want to start using, you need to download also the Azure Data Lake Storage add-in, which is available on the internet. You connect yourself to your subscription, and then you can start browsing. On top of that, you can start basically just writing what you want to do. So in this case, I am basically writing a simple sort of defined, redefined, slightly changed jobs. And some of them are very similar to, for instance, this one is very similar to Transact SQL. This one is, yeah, sort of like, running .NET or some, Python code or whatever. And then every time what you do is you say, where do you want to read? What do you want to do with this data? And then where do you want to store it? All those files are basically corresponding to my physical location in Azure Data Lake Storage. So if I go back to my to my Azure, I think, yeah, this is it. So if I go to Azure Data Lake Store, you can see, I'm just going to close this one again. So Data Explorer, and you will see that these are all my folders. And if I go quickly to my Visual Studio, I say, go to the folder Energy 2 and get all the files from here. So I go to Energy 2, and these are all my CSV files. I can quickly open one CSV file, and I can see what basically is inside. So you see a couple of integers, and that's about it. So this was part of a test for a energy consumption, sort of like IoT reading devices, where you can just get a lot of, data inside. You don't know what's there, how to read that, but, it will just give you an idea. And again, just read all the files, do something with the data, and then store the results again in this CSV file. You see, I'm using this extractor, which would be read, and then outputters, which would be sort of like store or insert. And I'm outputting the energy results right here. So energy results, and this is the result of the file which I will be using. So basically, I can now start the job here. I can tell to which Azure Data Lake I am connected, and I can also say advanced, how many ADUs I want to use. For instance, if I take, the more I take, the more money it will gonna cost me. The less, it will take some time, but it will not cost me that much. Or I can just go and copy this code and go to my portal, copy paste that code. I'm just going to call this job like energy reading, 1, sorry, and here if you, let's say I'm going to take a couple of AUs, you can immediately see, the estimated cost per minute. So I'm just going to go and take, all maximum 250, and I'm just going to go and submit the job. Now the system will prepare the model, the tree, how this data will be read and dealt with. So it will take a couple of seconds. Hopefully it's going to be fast, and then we will get a tree saying, just going to refresh, and showing how these files are going to be read and why the graph is not ready yet. This is interesting. It should, that's funny. Usually it should, okay, so there it is. So this is my graph, and every time I click on it, I will get some additional information. Now you can see that, it has 487 files basically to be dealt with, and then how many are the files to be read, and so on and so forth. And at the end, I want to do some aggregation. So aggregated basically is this box here is relating to this transact SQL, and then store all the files right here. So now that it's finished, I can immediately see, so this is my 00_2 results. I'm just going to refresh this, and it should be this one. And now I can click on it, for instance, and immediately see the results as well. So these are my results. Okay, so this is fairly simple for the starter, but I'm going to go and do much more. So the same I'm going to use now. First of all, I'm going to call the assembly external R. So it's like an extension of R, which basically will be able to send the load to our engine. And I'm going to go the same, read the same files, put the output, all the files together, for instance, then do some querying. And then I'm going to add my additional code list. So this is for the Slovenian regions, just additional code list with some ideas. And then what I'm going to do is basically I'm going to join those and store the results output to the data. And then I'm going to do some querying by the regions or by the readings and store the results up here. And then what I'm going to do is I'm going to introduce another table, and then I'm going to call the R to do some R resulting some correlations between, is there a correlation between region and energy consumption, if not, and that's it. So now what I'm going to do is basically I'm just going to say advanced before I click submit, just to make sure that I get all the possible AUs there is. And now I'm going to start this from my Visual Studio. So starting from Visual Studio, I should get all the results fairly the same as in Portal. While this is running, I'm going to go back to the slides. So we still have 10 minutes. So just to recap, Azure Data Lake in U-SQL is very good for processing big data. It is TSQL native to Transact SQL and .NET. It is not bound to any schema or any relational model. Of course, it is enterprise-ready security, and auditing is there for you to start immediately. It has Python and R support also built in, which means that you can do really some advanced statistics or some advanced modeling or predictive or machine learning. And as always, Microsoft would say, you can also increase your productivity. Then, if we still have some time, Jason will tell me, we can do, I've prepared a website, which is also Azure website, where you can go to this location and upload your selfie. And what will this do is basically I will call some PowerShell code, and the results will be reported back here. because we are sort of, 9 minutes left, I'm just going to show you what the results are, and I will show you the code. So if you go to this site, you will see also these results. So I'm just going to quickly escape from the presentation. In meantime, you can see that all these files and all these batch processes are being calculated, converted, etc., etc. I will go to my and now it's finished. And I can zoom in, for instance, I can click on and see some additional information about each of those vertices, what was inside, what was outputted, etc., etc. And also, it is very useful, as you can see, I get all the results where the data is being stored. About the metadata, I can get additional information where all the data is being stored. I can see the history, and I can also look into the diagnostics, which is also very useful. Now I'm just going to go quickly to this selfie uploader. For instance, let's say that you've done your selfie, uploaded the file here, and the result would be something like that. So you would have, I've used this cognitive part from the Cortana intelligence in U-SQL for image recognition. So for instance, in this case, you can see that number of people is 1, age is this one, gender, emotions, number of objects on the photo, and which are these objects. So this was done on some other occasion, so I'm just, due to the time pressure, I will not change anything here. I will just go to the Visual Studio, and I will show you the selfie uploader, for instance. So in this case, again, I am referencing all these libraries, which basically are Microsoft prepared them, so you just need to import them. And again, I am just saying, go to this location, extract the JPEGs, the files, do the vision cognition, so the image tagger, and then do the face recognition, so the gender and age, and then also the emotion analyzer. And what I'm going to do at the end is basically I'm just going to join all those results. Basically, you see it's a simple join, and then output the results to my CSV file. If I jump quickly to PowerShell, how does the PowerShell basically look like? It's just that you use, for instance, login Azure. I'm just going to make it bigger. So you're using login Azure RM account. You can always check what kind of lake storage you're using. And then in this case, just for the sake, so that you can see, I am copying and pasting all those files from the website. I'm downloading it on my computer, for instance, to run the code in the Visual Studio, or you can just do that in Azure. In Azure, you would simply, how would you do that is basically simply use the Azure Factory, where you would provision and define all the results, where you want to do, what you want to do, when you want to do it, and etc., etc. Okay, so I just quickly go through the PowerShell. I just went quickly through the PowerShell code, and 2 more minutes. The business use cases. What I've been working on was the energy consumption, which meant that there was a lot of small devices, cooling devices, and you would get constantly these small files, and there was no need really to worry about the schema. The files would just go into the Azure Data Lake, and then you would do this batch-orientated statistical analysis. Another fun was working on the image recognition for the hotels or any kind of sort of like a booking agency or whatever. I will come to that in the next slide. Microsoft is basically saying that they did this digital crime unit, which was analyzing the complex attack patterns, image processing, so it was image featurization and classification of the objects, and shopping recommendation. Again, shopping recommendation, very beautiful use case, because I'm also coming from the retail. But if you're running any kind of hotels or travel agency accommodations, what you can do is basically get a lot of images. You don't need to label them. The system will basically know what is on those images. For instance, the first image would be sea, beach, forest, hotel, etc., etc. And then you can start doing and building recommendation engine or the system based on what people liked or where people stayed, or just finding similarities between. And then of course at the end you can also do some sort of scoring and determining which image would be the best one and which not. In case of this energy consumption, so this is a case of data factory pipeline. You just basically what I've shown with a PowerShell or all those clicking, you can build this pipeline which will basically do the automation, scheduling, all the batch processing and querying for you, so you don't need to worry about anything. And at the end, as I said at the beginning, you can read and get all those results back through either APIs, or you can export it to the Power BI or reporting services, or any kind of website that I've built on and stuff like that. For those who are interested in any additional resources, I think this is quite a hefty set of URLs where you can find additional samples, files, or books, or videos on Channel 9 and stuff like that. So I would definitely recommend you to go there, especially if you're new to that. I would advise you not to start writing all those user-defined aggregates or user-defined objects on your own. Just try to Google it, go to GitHub, go to Microsoft blogs, Azure blogs, and find those samples there. A lot has been done already, so you don't need to do that. Thank you for your attention. Thank you for staying with me. I hope you've liked it. I hope you learned something new. And Jason, back to you.
Great. We do have 3 questions here that we can go through. Is U-SQL the only tool that can query the Azure Data Lake?
Yes. That's an interesting question. So to query the Azure Data Lake, yes. Yes, you can. For instance, you can. It's a kind of tricky question as well, because Azure Data Lake, you can push the data from data warehouse, or and you can query the data warehouse data using your classical transact SQL. But having all those data in different sets from different sources, bound, outbound, or structured, unstructured data, yes. U-SQL would be that one. You can also write some sort of .NET kind of select statements if you want, but U-SQL would get you the results much faster.
Okay.
Thank you.
How would we extract information from a video or MP3 file?
From the video, to be honest, I don't know. I've done photos, I've done text on the photos, I've done files, different kind of files, but I haven't done, also done, data from scraping the web and stuff like that, but haven't done videos. So to be honest, I cannot answer that. I don't want to answer because I don't want to give any wrong information. But it should be done as well. What I would suggest, you would definitely need some additional assembly where you would upload it, and how then you would read the data. That I don't want to answer because, as I said, I don't know.
Okay, great. And the last question is Azure Storage Account different from Data Lake Storage?
Can you repeat that, Azure?
Is the Azure Storage Account different from the Data Lake Storage?
The accounts, I'm using one subscription. I'm just creating a resource group, and then I'm just basically saying create me this or create me that. So technically 2 objects within one subscription which can communicate with each other, where you can get the data from, but everything basically is under one subscription. So you don't need to, or if you have multiple subscriptions, you can exchange that through subscriptions, but otherwise, yeah, it is a different object, but it's still the same, under the same, let's say, bonnet, or the same resource group or whatever. Because, for instance, in my case, I have one resource group and I have different objects in between, so that's it. But yeah, technically it's different, but it's the same. So
Cool. And actually, we have one more question that came in. Where should one use Data Lake?
If you have a lot of data where, you want to have the data stored cheaply, or you don't really want to care about if the schema is changed or anything, you can use the Data Lake. Data Lake is sort of like a new concept to traditional relational database or traditional HD orientated. So you just basically throw in anything. You don't need to worry about if it's changed or not, especially when it's really cheap, then you can just, use it. So I would say anywhere, anytime you can use that. Just beware of the costs, and that's it. You can also, there's also, deep or dark data lake, which means that, you store on a cheaper devices data that you don't need to read or write that many times and stuff like that. So, there are different concepts to that. But, as I said, you can store anything, just beware of the costs.
All right. And with that, we are actually over time. There's a couple more questions, but I'll just send those over to you, Tomaž,
okay,
so you can answer them offline.
Okay, cool.
All right. And with that, I'm going to stop the recording. Thank you again for presenting for us here today. And
thank
look forward to your session that's coming up actually next week.
Yeah, next week on
Thursday.
I think it's going to be Azure Machine Learning.
All right.
Thank you, and thank everybody participating, and hope you enjoyed. Good night.
Bye.